Leapfrog creates surfaces directly from borehole data, and as a result of that implicit modeling workflow, the surfaces can be easily updated when new data becomes available. For example, if an additional investigation phase is provided, the new boreholes can be imported into Leapfrog and the surfaces will be automatically updated to include that new information. This dynamic updating represents a huge time savings as models don't have to be started from scratch or manually updated with the addition of new data. In this video, we will discuss the options for adding new boreholes to an existing project and the resulting updates to the model. There are two options for importing new boreholes into the existing borehole database in Leapfrog: Append and Reload. The one you choose depends on what data your new table contains. If you have added new boreholes into a cumulative table that also contains holes that already exist in Leapfrog, they can be brought in using the Reload option. Reloading boreholes replaces the existing tables with the new ones. This can also be used if you've added any additional information to the existing columns, such as updated logging. Reloading is also the function we would use if errors in the data were fixed in the original database outside of Leapfrog and we wanted to update these tables in Leapfrog. The Append data option is used when the new data table contains only brand new borehole information that Leapfrog has not seen before. This is the option we are going to use in this project. Appending or reloading can either be performed for all the tables at once by right-clicking the boreholes object, or each individual table also has the option for append or reload. Before I demonstrate the dynamic updating process, I will quickly cover the options available for copying your geological models. Copying models can be useful for a number of different reasons, like testing out and comparing different modeling scenarios, but in this context, it will provide an easy way to evaluate the changes between the original model and the updated model. It is also possible to create a static copy of your model. When you copy a model, it remains dynamic, meaning that any time data is added, changed, or deleted in your project, the model will be updated. However, if you create a static copy, it will not change at all, no matter what happens to the data in the project. Therefore, a static copy is a good way to track changes in your model over time. I will make a static copy of this model so that I can review the changes that occur when I add my new boreholes to the project. To make a copy or a static copy, simply right-click the model of interest and select Copy or Static Copy. If you're creating a static copy, it will automatically be dated. Now that I have made a static copy of my model for comparison purposes, I'll append the new boreholes to the project by right-clicking the boreholes object in the project tree and selecting Append. I'll navigate to the new data tables and select the caller file. Not all of the available tables were selected automatically, so I'll click Add to select the remaining tables. When appending data, we need to check that the new data aligns with the data already in the project. The column summary for each file will show the columns and how each column will be imported. It is imperative that your new data tables contain the same columns as the original imported ones. In some cases, the new tables may have columns with different names from the original import, so certain columns may need to be remapped. However, in this case, all of the column headings in the new table match the column headings from the original imported tables, so the columns are all mapped appropriately for imports. You are unable to add any new columns at this stage. I'll click Next through the files and then select Finish. Your borehole data will now contain information from both investigation phases. Due to Leapfrog's implicit nature, the geological model, which is built directly from the borehole data, will also be updated when the borehole data is appended. All other downstream objects that are dependent on the boreholes, like combined models and cross-sections, will also be updated to reflect the new data. It may take a few minutes for your model to update. Prior to updating the models, Leapfrog will run through the grouping parameters that we've defined to auto-group all of the new intervals into our defined groups. Although the geological model in this project is being updated with the new borehole data, which we'll take a look at in a moment, the model's extents remain as those set when the model was created. In some cases, it may be necessary to update the model's extents and possibly the resolution of some or all of the surfaces. In this case, however, it is unnecessary as all the new drilling exists within the original model extents. If the boundary of the model needed changing to encompass new boreholes, this could be done easily by double-clicking the boundary object in the project tree and using the Enclose Object dropdown to select the geology table. This would update the model extents to the new drilling extents. Once updated, we can compare the updated model with the original. This helps you gain a better understanding of the difference new drilling has made. It is also very important to review the updated model to ensure any interpretations or edits that you may have made to the original model still make sense in the context of the new data. We made a static copy of our model before we appended the data, so we have a before and after version of the model. I'll start by comparing the silt volumes. I'll review the silt output volume from each model in the scene. Using these tools in the shapes list, I can adjust their appearances so that I can tell them apart.